Boston chapter of and the board of directors. And I'll be talking about 3 quick presentations. I thought I had an hour, but I went about 30 minutes. Anyway, what I'm going to first show is a bunch of slides of a proposed Mars mission that came out of a peaceful Mars conference about 10 years ago. And it's still reasonably valid and has nice pictures. The Mars talks were canceled in this session. I thought you might want to see it. And then I will move into what I call homesteading Mars, which is a way of building with local materials, making brick on the surface and building houses without bringing materials from Earth. And then the third part will be whether we can, the very first mission to Mars, stay there instead of a permanent base. There's a trade-off between a permanent base in the first mission versus a series of round-trip missions. So that's the sequence. Okay, so the question is, basically behind the whole National Space Society is where is a good place to live? Can people live beyond the Earth? Now, obviously, you're not going to have dandelions growing on asteroids. They just, they couldn't possibly evolve. But you could also say that life on Earth is a unit of all people in order to build life on Earth. Interesting thought. So maybe we are nature's way of getting off the Earth. And it's, some people would argue it's our destiny or our obligation. Where's a good place to live off the Earth? Well, there's by the way, this painting is about 10 years before the discovery of ice at the South Pole. And this is a painting of drilling for ice out at the South Pole. But even if
Speak up.
Yeah, we're saying the slide projector, please. I'm going to keep talking.
I don't know what it is.
Okay. The moon is not that good of a permanent place to live because of the vacuum, because you have to do mechanical processing. Okay.
Gotta take it out.
Okay. So would someone move that projector? Okay. Anyway, it would take mining and mechanical processing to get water and air on the moon. Next slide, please. Okay. Likewise, places in the outer solar system, you're so far from the sun that you would not have a lot of solar power. It's pretty clear you're not to live on Venus. Asteroids have the same problem the moon does. You have to do mechanical processing. You have to hold the air in. If you ever lose the air, you have to mine it back. On Mars, that's not true. So there's the asteroids. Space settlements are the same problem. You have to get the air from somewhere. I think someday there will be thousands more people living on space settlements than there are on Earth and Mars combined. But in the near term, I think Mars is the best place to go. Okay, so the next 20 slides are the painted by Carter Emart. He originally did them in pencil and then magic marker. You can believe that. And they are the classic Case for Mars mission design. It's the Case for Mars conference in Denver, about 1988 or so. You assemble the Mars craft in Earth orbit at a space station. You can see the landing craft, the white and black thing, you can see the fuel tanks. You assemble 3 of these craft. The crew comes up. When I'm showing this to elementary school, I say, your family is going Mars. That's the hand of a child playing with the ball that the parents gave that resembles the globe of Mars. 3 craft leave Earth orbit, chemical propulsion, dropping their fuel tanks. We now don't want to leave that much debris in space, but forgive them. They pass the moon, and these 3 ships link up. Notice they're not quite joined at the center where the 3 come together. So they are linking up as they do after they did a gravity assist passing the moon. And then they start spinning and have artificial gravity for maybe 8 months on the way to Mars. So the crew basically settles down in their apartments, and it's a little boring. They practice their key skills on the simulators. As they approach Mars, this is still spinning. You can see the silver solar panel dishes to collect solar energy. The blue things extending out at the far end are radiators. They passed photos and demos just for scale, about the size of Manhattan Island, a little larger. So, a lot more in asteroids than there is in the moons of Mars. And they drop off the landing craft. People climb the landing craft, drop off. As the landing craft come down, they see the largest volcano in the solar system. No, there is water on Mars. Those are water clouds. Is this review for everyone?
Yes.
Not the design thing.
Okay.
That's about Mars.
All right. Okay. The three volcanoes bigger than the state I come from, and the 8 river valleys. There was water flowing on Mars in the past. Okay. This particular biconic design came out of classified missile reentry bodies. It was just declassified shortly before this conference. They get a little bit of lift drag. Land on parachutes. Cargo craft have arrived beforehand. And by the way, I'm going to use that parachute cloth. That's going to be for sewing clothes later. So, climb down the steps. There's not a lot of existing usable resources on Mars. There's carbon dioxide, air, and there's dirt. And that's all you got to work with. You unpack your gear. This is a cargo craft that arrived ahead of time. Notice they have a cable attached to the nose. They're going to winch this cargo craft together with another cargo craft. So you pull 3 cargo crafts together, start covering them with dirt. You set up greenhouses, a pressurized garage, pressurized carbon dioxide. Okay, in the interior of the cargo craft, is outfitted to live in. In this case, they're going to live there for about a year. You use a drag line to pull dirt up and cover the cargo craft with radiation shield. This is a gas compression and separation unit. It's sort of basically a jet engine. You have a giant turbine that sucks the carbon dioxide in, which is less than 1% of first normal pressure. Compress it. In this particular design, they heated it and separated it into carbon monoxide and oxygen. And they used the carbon monoxide and oxygen as fuel to refuel their ascent vehicles that will take them back off the planet a year later. A year later, another craft comes by with a new crew. In the far right, we see the parachutes of the new crew arriving to take their place at the base. The original crew uses their 2-stage carbon monoxide vehicles to take off and rendezvous with the same craft that the new crew came in. And by the way, you'll be hearing from Bob Zubrin as soon as I'm through. He would use methane instead of carbon monoxide. It's just a trade-off. I think the conventional wisdom now is to use methane. You have a very long flight home. They get really bored. They have plenty of time to write their speeches they're going to give Congress. Air breakers, atmosphere, and land, and parade down Wall Street and shake hands with Congress. So that's the conclusion of the Case for Mars reference study. Are there any questions on that particular mission design? Very quickly.
How old is that? How long ago was that formulated?
About 1988, I believe. In Boulder, Colorado, at the Case for Mars conference. The Case for Mars conference had started when Congress told NASA not to spend any money on Mars, and a bunch of graduate students at the University of Boulder said, we're going to do it anyway. And every 3 years they've held conferences. I encourage you to come to the founding of the Mars Society this summer if you're interested. Bob will try to twist your arm into it.